This video is about the preparation of esters. The easiest way to prepare esters is to react an alcohol with an acyl chloride or an acid anhydride to yield us the ester. Both of these methods are very effective. Although the mechanism is very similar for both, we'll look at the mechanism of an alcohol reacting with an acyl chloride. The alcohol attacks the electrophilic carbonyl, forming the tetrahedral intermediate. The alkoxide then reforms the carbonyl, kicking out the chloride leaving group, after which a conjugate base removes the proton from the protonated ester to yield the final product. A much better way of making esters is Fischer esterification. In this reaction, you react an alcohol directly with a carboxylic acid in the presence of a strong acid to form your ester. This method is an improvement over the acyl chloride or the acid anhydride reaction because you need a carboxylic acid to make an acyl chloride or a acid anhydride, so we're skipping that middleman by reacting directly with the carboxylic acid. The mechanism is relatively important, so we're going to go over it right now. Initially, the carboxylic acid gets protonated by the strong acid. This protonated carboxylic acid is now a much stronger electrophile, so an alcohol is able to attack the carbonyl. The tetrahedral intermediate that forms then undergoes a proton shift to make one of the alcohols a water, which becomes a much better leaving group. At this point, one of the oxygens will donate its electrons to reform a carbonyl to kick out the water, giving us a protonated ester, which can then subsequently be deprotonated by that water that we reformed to yield our final ester product. Now let's do some practice problems. Please pause the video now because I am about to show the answers. Alright, here are the answers.